I think I've come quite as far as Paolo or a couple of others here, but yeah. Good morning, everyone. My name is Mike Nicholson. I work for Divio as a cloud solutions engineer. I'm British from the beginning, but I live in Stockholm, Sweden. So I've traveled from Stockholm for today. So today I'm going to talk about how 12-factor app principles helped Divio migrate over 10,000 Postgres instances without too many problems. That being the important part. No, that's not working now.
Isn't that?
No.
Can you
There we go. Okay, so just briefly, I will talk about why we wanted to do this in the first place, who Divio is and why it was actually relevant for us. What is a 12-factor app? What are the 12-factor app principles? And then the bulk of the talk will be talking about how the 12-factor actually helps with upgrading the database version and why it made it easy for us. So the why is quite easy. The final release of PostgreSQL 9.6 was scheduled back in August 2021 for the coming November. And in October 2021, AWS followed up on that and announced the end of support for Postgres 9.6 sometime early 2022. The date they announced has changed a couple of times. I think now it's actually dead. So who's Divio and why did we actually care about this? Why was it a big deal for us? Well, our tagline is multiple cloud management without the headaches. What that means in practice is we put a pause in front of your applications to make it easy for you to deploy in the cloud without caring about what's actually happening in the cloud. So in the instance of a database, you would add a database service to your application, to your project. We'd take care of all the setup on AWS or wherever, whichever cloud you wanted to deploy it on. You wouldn't need to care about the implementation details. You just say, I want a Postgres database. So we have, obviously, most of our customers have a database, a fairly common requirement. We do support multiple different databases, but Postgres is the most common one. We did MySQL. I think we've got a couple of Mongo ones somewhere and a few others. So almost all our customers, vast majority of the customers use Postgres, I think. Not all of them on 9.6, some of them are on later versions, but 9.6 until relatively recently was our default. So if you ask for a Postgres database, you would get a 9.6. So that meant we had quite a lot of database implementations currently running on Postgres 9.6. And since AWS is also our default target, if you don't want Azure or Google or something, it did mean that most of those were also on AWS. So we'll talk a little bit about 12-factor app. 12-factor app is a methodology particularly suitable for building software as a service applications. As the name suggests, it consists of 12 principles. And following these principles can help you build for portability, scalability, and continuous deployment pipelines. As I say, it's especially suitable for deploying applications in the cloud. Now, I'm not going to talk in depth about everything on the 12-factor today. Some things were more relevant for this particular use case than others. And also, this is only a 20-minute talk, so perhaps don't have time to cover everything. So I'm going to focus on the 6 primary ones that I think were of most interest just for this particular case. I think probably all of them came into play in some way or another, and a lot of them are dependent on other ones. But it's these ones in bold that will get a particular mention. If you're not familiar with the 12-factor app principles, there's the 12factor.net website. I do highly recommend people go and investigate it. It's well worth reading up on. So how do we use 12-factor? Well, two ways. We apply 12-factor principles to all our own code. So everything that we build, everything that we write, everything that we deploy follows all the 12-factor principles. That includes the control panel that we provide to our customers for them to set up their own applications for deployment in the cloud. But possibly more importantly, especially for this case, is that we enforce it on our users, which means they have to follow the 12-factor principles in order to deploy an application on Divio. That's actually easier than it might sound, and largely it means that you containerize your application and you ensure that you don't store any configuration or data in the container itself. If you're doing that, you're 95% of the way there to having followed the requirements that we need. So, the next slide is going to mention runbooks. So, it's a weird echo. So, just talk very quickly about what a runbook is. Basically, it's a procedure for executing a set of specific test steps that will automate a commonly run task or procedure in order to produce a specific outcome. Obviously, for this use case, that commonly run task procedure is upgrade a Postgres database from 9.6 to 13. The runbook wasn't new for this use case. We use runbooks for other things. I think one of the very common examples that we've implemented previously is Cloud Shift. So if a customer has their application in, for example, AWS US East 1, and they want to move it to Frankfurt, we have a runbook that will essentially pick everything up and drop it down in Frankfurt again, redeploy it there. So we have a number of runbooks that we define for different things. So here we wrote a new one specifically for upgrading Postgres. So the first 12-factor principle I'd like to talk about before I actually get to, it wasn't the next slide that mentioned runbooks, the one after this. First 12-factor principle I'd like to mention is admin processes. And 12-factor says about this, you run admin and management tasks as one-off processes. And if you dig a little deeper into this, what it actually means is that any maintenance task, any admin task, pretty much any task at all that you're running for your application, be it the main application itself or anything around the outside, is going to run in an identical environment to your actual long-running processes, your task itself, or perhaps background workers, that sort of thing. So maintenance tasks, short-lived tasks, they are first-class citizens just as much as the application itself is under the 12-factor principles. Yeah. So our upgrade runbook, you can't really, that's the whole runbook up this side here. You can't really see that, but that's just to indicate sort of the size of the thing and where we're at on it. But you can see it's not particularly long, not lots of steps in there. Implementation details are kind of abstracted away. We have some fairly human readable method names here to make it easier to show. But that does mean that I can sort of throw the runbook up here, and it should make it relatively simple for people to see what's actually going on. So the first thing we did was our runbooks consisted of a couple of things here, preconditions and operations. So preconditions in this case was we're only interested in customers in applications and environments that actually have a Postgres 9.6 database. Customers running on MySQL, not interesting. Customers running on Postgres 11, not interesting, not for this particular process. So the next 12-factor principle I talk about is configuration. And the important thing to think of here is that configuration is stored in the environment, not in the application. So admin processes, we've already talked about them. They're first-class citizens. They're built and deployed in exactly the same way as the application itself here. So, and a build under 12-factor principles is purely coming from the code base. There's no configuration involved in the build at all. We take the build, we take the code base and we turn that into a build. It doesn't know anything about what it's connecting to at that point. It doesn't know anything about the environment that it's going to be running in at that point. It's purely a build from the code base. The configuration is external to all of this and is injected into the application at runtime. So a build plus a configuration together will then give you a release. And this is quite important because it lets you then say the same build can be used for with different configurations to produce different releases here. It also let us use the same configuration for production or test when we were actually building these things, when we're actually building the runbook and testing it out. So it was just a question of testing the configuration rather than changing the build. So there's another 12-factor app principle that I won't go into huge detail on, but number 5 there, build, release, run, ties quite heavily into this, which is, yeah, you build your code, build from your code base, you release combines 2 steps, and then you can sort of run the final results of that. So, there we are. So principle number 8 is concurrency. And this is particularly important for scalability because all processes are of equal importance. Everything's basically running the same sort of thing, but it's the configuration that's determining what's happening in there. This makes it very easy to scale. And you scale out based on the type of process that you're talking about. So if you get a lot of heavy load on your application, you can add another web process. If you're running a shop application, it's Black Friday, you can double your number of web processes. If you've got a heavy worker load going, there's a lot of background tasks running, you can just add more worker processes. It's easy. I've put maintenance on here. Our maintenance is actually running as worker processes. So all our, I think I mentioned that, all our code is actually developed using Django, and we use RabbitMQ and Celery for background tasks. So I should have mentioned that earlier on. So yes, our maintenance tasks actually run as workers, but I wanted an extra example on the end there just to make it obvious. But what this does is makes it very easy to scale things. So when we were trying to upgrade a lot of databases during the same period here, we could just simply throw more worker processes at it. So onto the actual operations for the runbook. First thing we have to do is collect the service instances that we want to upgrade. So the service identifier here is referencing backing services, and that's another 12-factor app principle that we will get to in a moment. Let's see. Which is here. So 12-factor says about backing services is that we treat these as attached resources. So backing services, it can be a database, Redis cluster, object storage, anything else basically that you need to connect to your main application. Doesn't matter if that's a local service or a third-party service. This is treated as an entirely separate resource that is later on connected to your application via configuration. I'm making changes to the backing services. Largely is about changing configuration settings, injecting them into your application. So these sort of changes will take effect when you deploy, you then deploy your main application and it receives information about the new configuration. And this is rather critical for what we're about to do now with the databases. So first thing we want to do, we've got a 9.6 database. We want a Postgres 13 database. So the first thing we do is actually just provision a Postgres 13 database using the same configuration that we had for the 9.61. And that's it. That's at this point, when this is run, our project, the project that it's running on at the time, will now have two databases, 9.6 and a 13. Projects at this point, the application is still running against 9.6 database. It doesn't even know that the 13 exists at this point. It's just been 13 is there. It's on AWS. You could SSH into it if you wanted and start mucking around with it. But the application knows nothing about it yet because it hasn't been told about this configuration. The next few steps we run, at least during the automated, when we're doing it in the automated side, we do it in maintenance mode. And that's largely because we're going to be copying data around and we cannot guarantee when customer applications are going to be changing or adding or removing data. We did provide all the steps that we're talking about here. There are ways for the customers to do themselves. So we did provide instructions to say, if you want to do this with zero downtime, these are the steps to reproduce it. You just need to be sure that for these few steps here, that you're not changing your database. Otherwise, there's a risk that you'll lose a number of transactions during that period. Just the bit where the data is being copied around. So it was perfectly possible to do this with a zero downtime, but we couldn't make that assumption on behalf of anybody when we're doing it in an automated way. So. Okay, so 12-factor principle number 6 talks about processes. Execute the application as one or more stateless processes. So because the build comes from only code, doesn't know anything about the configuration at that point, and because the configuration is then injected into the app at runtime, it means the application itself is stateless. You can't guarantee that anything that you did earlier is still going to be around. You could cache, for example, if you needed to read in a largish file in some kind of process, you could cache that, do your read in, that would all be fine, but you could not guarantee that cache would still be there later. So, and what this means is, in practice, is that it's very easy to do a graceful shutdown and a relatively quick startup. Which is also quite important for what we need to do in a bit. So the next stage in the run book was to actually back up the data from the old services, the 9.6 ones, restore that same backup to the new services, and then to enable the new services. At this point, there's still two databases. They've both got the same data in them, but we haven't deployed the application at this point, so it's still running on the 9.6 database. It still doesn't know about the 13 database at this point. Again, you could SSH into 13 and run SQL and do whatever you wanted. It's there, it's provisioned, it's working, it's got the data in. It's just that the application does not yet know about it. So the next step is to deploy the new service instance. We do that by essentially deploying the application and telling it about the new configuration. We don't deploy, obviously, if it wasn't already deployed. So we do a quick check for that. We're not going to force deploy someone's application if they've taken it off themselves for whatever reasons they might have had. If that's the case, then those settings would take effect the next time they deployed it themselves. So, but otherwise, yes, we simply trigger the deploy process, which is combining a build with the new configuration, and that will then cause the application to know about the Postgres 13 database. The adopt equals true there is telling it that actually you can adopt the old build because we haven't changed anything about the build. There's no point in us trying to build a new container here because we haven't changed any customer code. all we've changed is the config. So we'll just reuse the old build. It saves time. Control factor number 9. So it talks about disposability and says maximize robustness with fast startup and graceful shutdown. And this is largely possible because, as we talked about a couple of slides back, the processes themselves, they are disposable because they are stateless. There are some things you need to think about when you're coding for this. This is that you should minimize startup time as much as possible yourself, whatever processes you need to run in the application. You should strive to minimize the runtime of any requests or anything coming into the application. So if you've got anything that runs for a long time, hand it off to a background process, provide a callback to let you grab a status for it whenever you need it, and just sort of let that run. Processes themselves should be either idempotent or roll back on termination to avoid any issues with that sort of thing. So, but this largely mirrors the process that we've done here. We changed our configuration because we set up the new database. We've changed the configuration to say we want to point it to the new database. We've stopped our application. We've redeployed it, combined the build with the configuration, and restarted it up there to pick the new configuration up. And finally, one last step. At this point, obviously, we're running on the Postgres 13. We do still have the 9.6 floating around, so we want to get rid of them. It's not particularly important for the customer. If we hadn't got rid of them, AWS would have come along a couple of months later probably and tried to force upgrade them to 13, something we particularly wanted. And also 10,000 database instances on AWS isn't cheap. So they're not renowned for being cheap. Yes, quite. So yes, we did not want 10,000 database instances that weren't really in use. So quick summary. Maintenance tasks are first-class citizens, just as important as the application itself or any other long-running tasks that you may have as part of that. Configuration is stored in the environment, so environment variables, secrets manager, whatever, not in the application itself. Backing services, in this case, the Postgres database, are attached resources. And the application is executed as one or more stateless processes. All of these help with fast startup and graceful shutdown, though there is some things that you need to think about when you're building things on the fast startup side. And if you do everything right, then this becomes then highly scalable and just lets you start and stop new processes as and when you need to do so. So I think that's it for me today. Thanks everyone for listening. Thank you to Benjamin and Emil for arranging this and letting me come and bore you all today and flick my talk upon you. Divio is at Divio. I'm at Mitch J. Nitch. And any questions?
Thank you so much. And like before, we'll start with questions from the audience. And there is a question there.
Runbook, is that something internal that you do?
A runbook's more of a concept that we've used. Yes, we've built our own implementation for runbooks here, but as you saw, it's basically a script. Yeah.
And I like the declarative syntax in a sense.
Yeah.
So it's similar to Ansible, but
yeah, essentially, there's a lot of concepts that have been lifted out of Ansible there to run this. It's the same sort of thing. We've abstracted away all of this deprovisioning old stuff. That's
tagging and so on.
Yeah.
The nice thing is you can also have custom code running inside that, because in Ansible it's YAML basically.
Yeah, yeah. Now, our runbooks are, everything's Python on our side. So yeah, our runbooks run as
Is
Python
it
there.
open source?
That isn't, no. Sorry. I can talk to our CTO and see what he says.
Yeah, that would be pretty
Yeah.
interesting.
Okay, great. So the question was if the run book that Mike has shown was internal or based on Django. Okay, we'll take the next question down there. Yeah.
I'm wondering about, we're talking about statelessness and multiple processing and stuff like that. And it's a lot of things going on, actually. It's
Yes.
the same thing, but in a huge scale, as you can say.
Yes.
How do you do surveillance and monitoring for these kind of things? Some kind of third-party product, or you created your own stuff to get some kind of dashboard or cockpit for it? I mean, if anything goes wrong, just a little thing goes wrong, you can miss it.
We do integrate. Yeah, we do integrate with a number of. Sorry, you want to repeat the question?
Yeah.
I beg your pardon.
The question is, quite frankly, how do you do monitoring of all these processes that you're running?
We do use a number of third-party tools for the error tracking stuff. Things, for example, we have Sentry. We do have some internal metrics that we use as well. That's our own solution that's plugging into this stuff. But yeah, and we have Sentry. We Datadog. We use with a few other things that we plug into here. So there's a reasonable amount of monitoring going on. I mean, we run. Think about the fact we're upgrading 10,000 databases here. I mean, they're all customer databases. So we've got a lot of ongoing monitoring for all of these customer sites anyway. So we didn't have to do anything extra for this. We already had all this monitoring set up.
Yes, in the middle.
You mentioned in the prelims to the talk that doing it this way fixed most of the difficulties with upgrading Postgres so far. Would you be prepared to speak to, in a high level, some of those remaining difficulties and whether they were intrinsic to that upgrade or the scale you were doing it at or any of that kind of thing?
Are there any intrinsic issues remaining after the 12 factor?
From a technical perspective, not really, to be honest. This let us take care of everything pretty smoothly. I think we did have a bug in the runbook earlier on when we ran a couple of smaller batches, and that was fixed very quickly, and we sorted that out. I think any sharp edges on this one were more to do with customers and what they wanted and what they didn't want to do and what they were complaining about. Yes, we had a few of those cases, but yeah, we got to handle. And because we provided all the steps that we put here, you could do them manually yourself as well via our control panel. So you could go and do the backups and the restore and put it all down without actually taking the application online. That was usually enough to solve the problem for any customers that had any issues with it. So. Yeah.
The internet is trying to catch up on the question asking. Unfortunately, the question has already been asked.
Okay.
Just a reminder that everyone's very interested in the source code of this.
Oh, the runbooks. Okay. Yes, I'll have to talk to our CTO when I get back. Yeah.
Any more questions? Yeah.
I'm struggling with disposability with the code base I'm managing at work. So, and I can manipulate that code because that's my job.
Yeah.
But you're running code on behalf of your clients.
Yes.
How do you make sure that we shouldn't run long-running streaming responses and long-running jobs, but how do you ensure that your clients' code bases don't do this? When do you terminate? How do you dispose of service that you are not totally in control of?
Yeah. Long-running services, how do you dispose of something that you don't have control of?
Yeah, specifically customer. I mean, in general, we don't as a general rule. If a customer's got some kind of long-running process, it's not ideal, but we're not going to just go along and shut it down for whenever. Yeah, it is. A lot of it is up to them. They need to build for this sort of stuff in the first place. As I said, we do enforce these principles on our customers as well. And in order to deploy, the application has to be containerized and it has to follow a certain number of guidelines. I don't say that all our customers are following them fully when it comes to maybe, especially I think what you're talking about with long-running requests, maybe. I'm almost certain there's people that are running some longer runs without providing callbacks. And we see stuff like that pop up occasionally on support questions and things. And usually the advice is, well, we suggest you refactor in this way, essentially. So, I think that is usually, we'll give the customer some guidance when we see that this stuff, when this stuff happens, basically. Because you're right, not everybody builds for idempotency or rollbacks or that sort of thing. So, the human factor, I think, is the answer. Yeah.
The 13th factor.
Yes.
Any other questions? I have a question, and we do have time for more questions, so don't hesitate. But in order to get 12 factors introduced in your project or at your workplace, do you meet any obstacles, any friction? When is it too late to go for 12 factor? Can you always introduce them one factor at a time?
The first half of that question, I can't answer for you, I'm afraid, because they did that before I started there. So I'm not sure what they meant. And to be honest, I think it's always been there for them. I think they've built this has been inbuilt from the start. So I don't think they've seen a lot of friction with that sort of thing. So, sorry, now I've forgotten the second part of the question. What was that?
Yeah, is it ever too late, or how would you introduce it when you haven't really followed it?
I don't think it's ever too late, and I think a lot of people are probably introducing a number of these factors anyway, simply by moving towards Docker and containerizing everything, because when you're doing that does kind of put some restrictions on you as well, I think, and you end up doing some of this anyway, even if you don't realize you're doing it. There are some rough edges sometimes. For example, Django migrations, you can't build them into your build process, because when you build the code base into a build, doesn't have the configuration, so it's not connected to a database. So your migrations would run, but they're not going to run against anything. So we have this concept of sort of release commands, which is the final thing that runs once everything's been put together along the 12 factor principles. It will do those remaining couple of things, like the migrations, once we've finally injected the configuration and sort of wired the two things together and said, now the app's connected to this database. So, I'm not really sure if that answered the question, to be honest, but I'm not sure
Yeah, I mean, it's a good point that we may have already introduced 12 factors without knowing it, so that takes a part of the heat off from...
I think probably people have recently sort of tried to containerize things and Dockerize stuff, have probably done some of this without considering that was what they were actually doing.
Yeah.
So, yeah.
Let's see. Any more questions from the crowd here? I don't find any questions from the internet. Is that correct? There isn't. All right. But let's give a big hand to Mike.
Thank you.